Okay, so today I have to discuss on next reaction intermediate, that is nitrene. Okay, so from the naming you can understand that is nitrene basically consists of nitrogen atom. Okay, you may guess. Okay, तो क्या होता है, हर वक्त ऐसा नहीं होता है आपका जो नेमिंग है वो ही वो जो आपको जो प्रेजेंट करेगा वो ही होगा, ऐसा नहीं होता है। पर नाइट्रीन से हम थोड़ा बहुत रिलेट कर सकते हैं किसके साथ, नाइट्रोजन के साथ। ओके, सो नॉट ऑलवेज बी दैट इज द ट्रू, दैट इज द नेम ऑलवेज सजेस्ट द सेम द राइट थिंग, दैट इज नॉट ऑलवेज ओके, बट sometimes name can predict, name can suggest some clue about this, about the word. Okay, so that's why 19 suggested the word, that is the not a word but a letter, that is nitrogen. Okay, so now we have to start with nitrene intermediate. Okay, so for better clarity I will say that is, I want to say that is nitrene basically, actually nitrene is consist of nitrogen. Okay, simple. Okay, already I discussed carbocation, carbanion, carbene. Okay, so these all are basically consist of carbon atom. Okay, clear? But nitrene is basically consist of nitrogen atom. This is the difference. Okay, clear? So now I have to start with it. Nitrene are basically non-ionizable, short-lived. Obviously this is an intermediate, so you know intermediates always be short-lived. That does not depend on which type of intermediate that's are there. Okay, always remember intermediate should be short-lived. Okay, always be, that is intermediate is nothing but that is a short-living species which should be produced before product formation and after reaction of reactant. Okay, जो reactant and product का जो बीच में जो reaction होता है उसका ठीक middle वाला product होता है intermediate. Okay, and there must be a difference between transition state and intermediate. Intermediate, though intermediate is a short living species, but still we can trap it. Okay, and transition state normally never be trapped. Okay, and transition state always give the idea about how the bond break and bond make in this procedure. Okay, nothing but, and that is a high energetic thing. Okay, but when we consider intermediate is a short living species and we can trap it. And not only that, many reactions prove it that there should be a intermediate which are produced. Okay, so now we have to start with nitrene. Nitrene is basically non-ionizable and that should be short-lived and that must be highly reactive and also electron deficient species. That means electron deficient species like that is, as for example, carbene is also electron deficient species. Electron deficient species can also be called as electrophile. Okay, similar things can be happen for nitrene. Nitrene is also electron deficient species. Nitrene itself also act as electrophile. Okay, clear? Like carbenes. Okay, and having 6 electron on a nitrogen atom. This is the basic information of nitrene, that is nitrene should be non-ionizable, nitrene should be short-lived, nitrene should be highly reactive, as this is nothing but that this is an intermediate and intermediates always be reactive. If the intermediate is stable enough, so their reactivity may be down, but that also be still reactive. Okay, and next one, electron deficient species like carbene. Okay, and next one, having 6 electrons on a nitrogen atom. So this all category, these all things, if you write step by step, okay, so these all are the characteristics of nitrogen. Clear? Okay, next one are also called as agenes, imines and imidogens. Okay, so nitrogen can also be called as agenes, imines and imidogens. So these all the names are nothing but They are also the name, or they are all the name of nitrene. Okay, nothing but. What you understand by the naming of nitrene? That is same with the term of agene, imine and imidogens. Okay. Now acyl nitrene, acetyl nitrene, alkyl nitrene. They are the example of nitrene. Clear? Okay, next. Nitrenes are derivative of hydrogen bond nitrogen. Nothing but. So this is the simplest form of hydrogen nitrogen. You can replace the hydrogen by any other alkyl group, aryl group. So you can get also nitrene. Okay. But the simplest form is hydrogen bond nitrogen. ओके जो सिंपलेस्ट फॉर्म होता है वो हाइड्रोजन बॉन्ड नाइट्रोजन होता है. वो हाइड्रोजन को आप रिप्लेस करो तो आप बहुत सारा टाइप का, बहुत वेरियस टाइप का नाइट्रीन आप पाओगे, पर वहाँ पर याद रखना आपका जो सिंपल फॉर्म है वो हाइड्रोजन नाइट्रोजन है. एज फॉर एग्जाम्पल, व्हेन वी कॉल अबाउट द हाइड्रोकार्बन, first when we introduce what are the hydrocarbon, so we first introduce single bond, double bond and triple bond. Okay, so we never write ethane first as a example of single bond compound, single bond hydrocarbon. We never consider first ethane first. We first consider methane. Okay, so from methane, this all the example that should be used. Okay, so we always consider the simplest one. Why? There must be two reasons there. One reason, that is this is a better for understanding, and second for there must be some chemical relationship is there. Okay, suppose methane. So all the hydrogen, if you replace any one hydrogen by carbon, CH3, so there must be another hydrocarbon can be produced. Okay, if you replace hydrogen by any other functional group, suppose OH or Cl or any other group, that also produce derivative of hydrocarbon. Okay, so that means there must be a chemical relationship between simplest form with the other complex forms. Okay, so that's why you have to first study with the simplex form, and then you have to step by step learn all the matter. Okay, right? Okay, next. Now there must be the preparation also there. How the nitrene should be produced. Okay. So first one, the first process is alpha elimination. Always remember, suppose any functional group is present here. There must be OH. There must be so many carbon are there. Suppose there must be 3 carbon is present. This. Okay. So always remember, the first near of carbon is called as alpha. Second one is called as beta. And third one is called as gamma. ओके, जो OH होता है, सपोज OH बोलो, कोई भी फंक्शनल ग्रुप बोलो, उसके रेस्पेक्ट में जो भी कार्बन पहले आएगा वो अल्फा पोजीशन होगा, जो भी दूसरा वाला पोजीशन होगा वो बीटा होगा, और तीसरा वाला पोजीशन क्या होगा? गामा पोजीशन होगा. एंड व्हेन द एलिमिनेशन शुड बी टेक प्लेस एट ए पर्टिकुलर अल्फा पोजीशन, दिस इज कॉल्ड अल्फा एलिमिनेशन. ओके, एंड when the elimination can be take place at a beta position, that is called beta elimination, and when the elimination can be take place when take place in gamma position, that is also called gamma elimination. Clear? Okay. Most elimination are beta elimination. Okay, but gamma elimination as well as alpha elimination can also be take place. जो alpha elimination, gamma elimination वो भी होता है. So first one, there must be the acidic hydrogen. Why? Because there must be this RCO group, that is also electron withdrawing group. This Br is also electron withdrawing group. Okay. Okay. So that's why these hydrogen are much more acidic. So this base can abstract it, and there must be carbon ion can be produced. Then Br can be released. So ultimately nitrene can be produced. Okay. But there must be a question can be arise in your mind, that is Br minus, Br, bromine or any other halogen that also show plus R along with minus I. Why we emphasis on minus I more? Because most of the cases as experimental analysis, as experimentally, they all show minus I predominate in most of the cases and ignore plus R. Okay, some rare cases where plus are p dominant. Okay, so that's why this can be happen. Okay, next one from azide. एजाइड से भी होता है. एजाइड मतलब क्या होता है, वहाँ पर 3 नाइट्रोजन होगा. In azide there should be 3 nitrogen should be present, but the 3 nitrogen never be leave as it is. Okay, because always same, but 3 nitrogen isolated form are not stable. There must be always tendency to leave as a N2 or molecular nitrogen. Okay, because molecular nitrogen that is much more stable. Okay, so that's why when you introduce H nu or heat, when heat use, that is called pyrolysis. जब आप हीट यूज़ करोगे उसको पायरोलाइसिस बोलता है. जब आप एच न्यू और कोई भी फोटो एनर्जी यूज़ करोगे तो उसको बोलता है फोटोलाइसिस. ओके, so when heat or photolysis, photo energy that should be used, on that case N2 can be released, and these two form is regenerative structure of each other, and there must be this nitrene along with N2 can be released. And when in any reaction, any gaseous substance when released, there must be delage or entropy that should be much increases, much amount of increases. Okay, so on that case, this is delage much more positive. So when delage much more positive, there must be high possibility that del G should be negative. And when del G should be negative, the reaction gets spontaneous way. Okay, so that's why this is favorable. आपका कोई भी रिएक्शन में जब भी कोई गैस रिलीज होगा, सपोज N2 नाइट्रोजन, N ट्रिपल बॉन्ड एंड आपको तो पता होता है डिसोसिएशन एनर्जी बहुत ही हाई होता है. N ट्रिपल बॉन्ड तो ऐसे ही हाई होता है बिकॉज वहाँ पर एक सिग्मा बॉन्ड होगा, वो तो एंड ऑन ओवरलैप होगा. सिग्मा बॉन्ड तो बहुत सबसे ज़्यादा स्ट्रॉन्ग होता है. उसके बाद 2 और सपोर्टिंग 2 लेटरल ओवरलैप होता है, 2 पाई बॉन्ड होता है. तो ऑलरेडी ट्रिपल बॉन्ड ज़्यादा स्ट्रॉन्ग होता है. उसके साथ नाइट्रोजन ट्रिपल बॉन्ड नाइट्रोजन जो होता है उसका डिसोसिएशन एनर्जी और बाकी सब ट्रिपल बॉन्ड से भी अच्छा खासा मतलब स्टेबल होता है. ठीक है, बहुत अच्छा डिसोसिएशन एनर्जी होता है, बहुत हाई डिसोसिएशन एनर्जी होता है. तो इसलिए एन ट्रिपल बॉन्ड एन बॉन्ड बहुत ही स्टेबल होता है. इसलिए जब भी आप कोई भी रिएक्शन में 3 नाइट्रोजन एटम और 2 नाइट्रोजन एटम देखोगे या फिर N2 अटैच हुआ है ऐसा देखोगे, तब ज़्यादातर केस में देखोगे N2 रिलीज हो रहा है एज ए गैस. सो व्हेन गैस आर रिलीज्ड, there should be delay or randomness that should be increases. When in any procedure randomness increases, that means overall entropy increases. When entropy increases, entropy gives the sign positive. When del S positive, you know del G equal to del H minus T del S. del H suppose not significantly change. जो एंथैल्पी है वो ज़्यादा चेंज नहीं हुआ, तो तब कौन सा इफेक्ट ज़्यादा इफेक्ट करेगा? del S. So when del S much negative, del S much positive, del G much negative. There must be possibility. Okay, and when the possibility comes true, that is del S equal to positive, del G equal to negative, there must be the reaction overall gets favorable. But if you ignore del G, suppose del G you never know, that is del H, that is enthalpy का जो value है वो क्या है, you never know the value of enthalpy. So how you can conclude del G should be negative, right? So on that case, always remember if del G negative or positive, this is the defined thing. But always remember when randomness increases in any process or any reaction, the reaction should be favorable in terms of entropy. If you ignore del G, if you ignore Gibbs energy, you can consider only the del S. There also remember del S, that should be when much positive, as there must be stable molecule release, as there must be कोई भी gas, the gaseous release, or there must be some others more than products that should be produced, so which are also stable. So in those cases, sometimes del S gets much higher value, much positive. So on that case, in terms of entropy, this reaction goes to be favorable. This is the case. Suppose, as for example, in any reaction, you forget del G, okay, and you never see that is any change of del S, that is any change of entropy. But you see, there must be the pi bond should be big and sigma bond that should be produced. Pi bond that should be big and sigma bond that should be produced. In which reaction this happen? Are you know? This is can be happen for the case of Diels-Alder reaction, for the case of electrocyclic reaction, that means pericyclic reaction. So on those cases there must be pi bond that should be break and sigma bond that should be produced, and you remember sigma bond is much stronger than pi bond, and this is the exothermic process, heat will be released. So on this case del H enthalpy that should be negative, and in terms of enthalpy the reaction goes to favorable. Okay, so you have to know that is 3 terms, del S, del H, del G. If you never know the del G value, because in predicting the value of del G, there you have to know temperature, you have to know enthalpy, you have to know entropy. But in many reactions, the 3 term never be given. Okay, so on that time you have to predict the reaction favorable or not, or support the reaction. You can you can understand about the entropy factor and also enthalpy factor. Clear? Okay. Next one. Next one from iminoiodines. Okay. So on that case also you have to provide heat or H photo energy. आपको heat और photo energy देना है. On that case there must be iodine that should be produced, along with there must be nitrene can be produced. Okay. Next one, nitrene are also basically 2 types. Nitrene also 2 types. Why? Because nitrene, one is singlet nitrene, another is triplet nitrene. Okay. As you know, carbene also 2 types. That is singlet carbene as well as triplet carbene. So similar case can be take place on that case, that is nitrene also basically 2 types, that is must be singlet carbene as well as triplet carbene. So singlet carbene, always remember there must be 1 orbital having 2 electrons. Okay, basically 1 lone pair also there in 1 orbital. This lone pair that is basically common in both of the cases. Okay, so this is not a difference, but the next the difference is there, that is here 1 orbital having 2 electron and here 2 defined orbital having 1 electron each. Okay, respectively. So this is the differentiating factor. That is in singlet carbene there should be 1 lone pair is still there. In triplet carbene there also 1 lone pair is still there. Okay, this is not a differentiating factor. जो आप सिंगलेट कार्बिन देख रहे हो वहाँ पर भी 1 लोन पेयर है ऑलरेडी 1 ऑर्बिटल में, ट्रिपलेट कार्बिन में भी 1 ऑर्बिटल में 1 इलेक्ट्रॉन है. तो वो डिफरेंशिएटिंग फैक्टर या डिफरेंस करने का फैक्टर नहीं है. डिफरेंस करने का फैक्टर वो है कि आपका सिंगलेट कार्बिन में 1 ऑर्बिटल में 1 और ऑर्बिटल में पेयर्ड इलेक्ट्रॉन है और ट्रिपलेट कार्बिन में और 2 ऑर्बिटल में 1 करके इलेक्ट्रॉन है. ओके, तो दिस इज द डिफरेंशिएटिंग फैक्टर. So now the another process of preparation, that is photolysis, and remember that these 2 orbitals should be degenerate. That means degenerate means what? Energy same or not? What I tell already, I discussed in the previous lectures. So this should be the homework. Okay, if you never tell, if you never say about this, I will comment in the videos. Okay, next on photolysis, here also N2 that should be released and there must be simple nitrene that should be produced. Here also simple nitrene can be produced. Now next procedure, that is oxidation reduction method. That is the last method. Oxidation reduction method, when compounds contain NH group, suppose any NH group is there, are oxidized with lead tetraacetate, that is PbOAc whole 4, and activated mercuric oxide. Okay, and manganese oxide, there must be nitrogens can be produced. So you can use that is NH containing any compound and that should be oxidized with lead tetraacetate or and also activated mercuric oxide as also manganese oxide, then the outcome should be nitrene. Okay, so aromatic nitro or nitroso compound and heating, that is POAT whole 3, that is triethyl phosphate, the reducing agent is basically nitrene. आपका जो POAT whole 3 that should be used, that should be produced the nitrene. Okay, so there must be the tetraacetate can be used, and there must be this NH2 can be converted into nitrene. This NH2 that should be converted into nitrene. Here also POAT whole 3 that also be used, that is nitroso compound, and that should be produced nitrene. Okay, so behave the nitrene that should be behave like as electrophile. Electrophile, that means electron loving group. Where the electron density higher, there should be this electrophile attached with it. जहाँ पर आपका इलेक्ट्रॉन डेंसिटी ज़्यादा मिले वहाँ पर ही इलेक्ट्रॉन लविंग ग्रुप दैट मीन्स इलेक्ट्रोफाइल अटैक कर देता है. ठीक है, तो कार्बिन जैसे इलेक्ट्रोफाइल है, कार्बिन जैसे इलेक्ट्रॉन डेफिशिएंट स्पीसीज है, वैसे ही आपका नाइट्रीन भी इलेक्ट्रॉन डेफिशिएंट और इलेक्ट्रोफाइल है. नथिंग but there must be some reaction can be happen by nitrene, as nitrene is intermediate and also highly reactive, so obviously it can undergo in some reactions. Okay, and you have to know about this reaction, and that I will tell next class. Okay, so the reaction should be addition, the reaction should be insertion, the reaction should be rearrangement. So after this in the so that means what the things what I say in this lecture, that is nitrene. The basic property, nitrene should be short-lived. Nitrene, as a nitrene is an intermediate, so obviously it should be short-lived, it should be highly reactive. Okay, and it can be trapped, and also it is an electron deficient species, so obviously it is a behaves like electrophile. Okay, and like carbon. And nitrene should be non-ionizable, and that is there must be various type of nitrene can be there. The simplest form is nitrogen hydrogen bond, and this hydrogen can be replaced by any other group and can produce variety of nitrines. Okay, next on preparation, alpha elimination. Alpha means that is any with respect to any functional group, the nearest position is called alpha, the second nearest position is called beta, and third nearest position is called as gamma. Nothing but आपका जो भी फंक्शन ग्रुप होगा उसका ठीक फर्स्ट पोजीशन जो होगा उसके रेस्पेक्ट में फर्स्ट पोजीशन जो होगा वो अल्फा होगा, सेकेंड जो पोजीशन वो बीटा, एंड थर्ड जो पोजीशन होगा वो गामा होगा. From azide pyrolysis, there should be N2 release by introducing H or heat. There should be also nitrene can be produced. And from iminoiodines, वहाँ पर also आपका हेलोएनिन प्रोड्यूस होता है, उसके साथ नाइट्रीन. नाइट्रीन कैन बी बेसिकली can be divided, can be classified as two types. One should be that is singlet carbene, other should be triplet carbene. Singlet carbene, that means there must be already in singlet carbene and triplet carbene the similarity is there, both having one lone pair in one orbital. Okay, this is not a differentiating factor, this is a similarity. Okay, next differentiating factor is that is excluding this lone pair. You can see that is in singlet carbene one other lobe having 2 electron paired. Okay, and triplet having 2 other electron which should be degenerate, and there must be 1 electron each. Okay, so आपका जो दो ट्रिपलेट कार्बिन सिंगलेट कार्बिन है, दोनों का स्ट्रक्चर में क्या डिफरेंस है? दोनों का ही एक लोन पेयर होता है जो कॉमन होता है, उसको छोड़कर आप देखो तो सिंगलेट कार्बिन में एक ऑर्बिटल में 2 इलेक्ट्रॉन पेयर्ड है, और दूसरा जो ट्रिपलेट कार्बिन वहाँ पर दो ऑर्बिटल में एक एक करके एक इलेक्ट्रॉन है. ठीक है, next one, the procedure of preparation. First one, photolysis procedure. There should be N2, that is nitrogen, molecular nitrogen that should be released, and on that case nitrogen can be produced. Next one, oxidation reduction process. There should be any NH containing compound there. When you introduce late tetraacetate, there should be also nitrogen can be produced, along with some other that is must be from azide, from iminoiodines, from alpha elimination. There must be various way nitrogen can be produced. Okay, so this is the thing. Okay, up to this, and today I discuss so many things. Next day I will discuss the reactions which should be can be carried out by nitrogen. Okay, next day I will discuss the reaction where carbene should be participate. Not carbene, nitrogen should be participate. Okay, so up to this. Okay.